Hey guys, it's Mr. Katz. This is lesson one. In case you were absent, this is just a couple of things that we learned today. I'm going to go through the flip chart, but I'm going to go pretty quickly through the flip chart. This was our warm up. If you just wanted to, to do it and see what we did for a warm up. Our agenda today, we're going to take some notes. Going to give you two examples. We're going to go over some vocabulary, and then we have a summarizer at the end. And again, as we're going through this, if I'm going too quick, pause the video, and you could either replay it or just process it. These were the major concepts, but basically what we were saying was that you can use when you have an equation, you could plug whatever you want in for y and solve for x, or you can, plug things in for x as long as you do it in both places, and you can get the y value. Well, when you want to know, one of the x-intercepts are really important in solving a lot of these problems. We call the x-intercepts the roots. They're essentially the solution to the equation. So if you have an equation and you want to find the x-intercepts, one way to do it is that what you're really doing is you're plugging in a 0 in for y. And when you have a 0 in for y, it's not like solving an equation like we used to have in quarter one. In quarter one, we had an equation like 3x plus 2 equals 9. And you can solve for x, find out what x is for it to equal 9 by moving everything over, subtracting 2, and then dividing by 3. It's really easy. When you have this equation equal to 0, since there's an x here and there's an x here, and you can't just cancel it out by dividing by x, there's a different method that you have to use to solve for x. Find out what x has to be in this equation. Well, what we've learned is we use what is called the zero product property. And basically what that is that if you have a multiplication problem, like you do here, like 7 times x, and it's equal to 0, you know either the x has to be 0, because the only thing times something else that would equal 0 is when you're multiplying by 0. Here, if you have a times b equals 0, either a has to be 0 or b has to be 0, or they both could be 0, because the only way you can multiply two things and get 0 is if one of them is 0, either a or b. And right here, same kind of concept. If negative 5 times a times b equals 0, either the a or the b is going to have to be 0. So that's what the zero product property is. It's just saying that if you have a multiplication problem that equals 0, you can set factor 1 and factor 2 equal to 0, because one of these has to be 0. Let me give you two examples of that. Here, you have x plus 14 times x minus 9 equals 0. Well, this is already in factored form. You actually have a multiplication problem, this times this, which equals 0. So one of these two things are going to have to end up being 0. So what you can do is you can set the x plus 14, the first factor, we know this whole thing could equal 0, or x minus 9 could equal 0. And when you solve each of them for x, you get negative 14, add 9 to both sides here, and you get positive 9. These are the two things that x could be in order for this equation equal 0. Either both of them are 9, or both of them are negative 14. And either way, either which way you made x, as long as it's one of these two things, this will equal 0. So I can write this in a set form, meaning the answers to x are either negative 14 or 9. These are the two solution sets. This is the solution set. These are our two solutions for x. Here's another example. You have a trinomial that equals 0. But here it's not in factored form. But we can factor this in order to create a multiplication problem. So here, because it's 1x squared, I'm looking for the two things that multiply to negative 56 that equal a positive 1 when you add them. And that's negative 7 and positive 8. So our two factors are x minus 7 and x plus 8, which equals 0. So now that I've factored this side, I have a multiplication problem that equals 0. So one of these, either x minus 7 has to equal 0, or x plus 8 equals 0. And when you solve for both, you get your two answers of x equals negative 8 or x equals 7. And so that means that if you plugged a 7 into this x and this x, it would equal 0. Or if you plugged a negative 8 in for this x and this x, you would get an answer of 0. So our solution set is negative 8 and 7. So on page 4 of your packet, there's some example problems for you to do. Actually, before we do that, I forgot to mention that the answers we get for x, because we're making y equal to 0 in all these problems, the answers we get are actually the x-intercepts. or the roots or the zeros. These are other ways that we call the x-intercepts. We call them roots, we call them zeros, or we can just simply refer to them as the solution of the problem. The answer for x when y is 0. And that's really all you're doing when you're talking about root zeros or solutions. So here are 6 problems that we did in class, and I want you to go ahead and do them, and then pause the video and just practice them and see if you get them right. And then when you're done, you can actually do your homework. And once you're done with these problems, go ahead and unpause it, and then I will go through each solution. So I'm not going to show all my work just so it's easier to write, but in this problem, you actually had already in factored form which equaled 0. So if you set this equal to 0, or this equal to 0, you get your 2 answers, which are positive 24 and positive 37. And I'm not going to write it as a solution set, but those would be your 2 answers in your solution set. Here, it equals 5, so you can't have it equal to 5. You actually have to move the 5 over so it equals 0. So I can subtract 5 on both sides and combine it with the positive 29. You get x squared plus 10x plus 24 equals 0. And then if I factor this side into x plus 6 times x plus 4, you now can set each of these equal to 0. You get 2 answers eventually of x equals negative 6 and x equals negative 4. Here, already in factored form, and it equals 0. So I can set this equal to 0 and this equal to 0. And you get your 2 answers of x equals negative 78. And I remember, I'm not showing my work here. I'm just giving you the answers because these are already set. You set this one and this one both equal to 0 and solve. And those are your 2 answers. Here, you add 4 to both sides. You get x squared minus 11x plus 18 equals 0. And this side will factor into x minus 2 and x minus 9. And then if you set this equal to 0 and this equal to 0, which you should show your work, you get the 2 answers of x equals 2 and x equals positive 9. This one was a tricky one for some people. This is still in factored form. They took out a GCF of x, but you still have x times x plus 12. So you set each one of those equal to 0. And when you set x equal to 0, it's already solved. And when you set x plus 12 equal to 0, you get x equals negative 12. So your 2 answers are negative 12, and x could also be 0. Here, you have to subtract an x squared on both sides, which you could only combine with the other thing that's x squared. That becomes 0 equals, and then you get x squared, 2x squared minus 1x squared is 1x squared, minus 2x minus 35. You factor this side, and I'm going to do it up here, but down here you get actually x minus 7 times x plus 5, which equals 0. And when you set each of these equal to 0, you end up getting x equals positive 7 and x equals negative 5. And that's what we did in class. The only other thing that we're going to do in class actually tomorrow, we're going to do as a warm-up is answer the summarizer, which is this question, which if you can pause it, but this is what we'll do in lesson 2.